Hi gentlemen, so today we're going to look at the equations of an ellipse. So we did the circle, so now we're going to look at an ellipse and the standard form. So an ellipse is a set of points in a plane whose distance from two fixed points, called the foci, which are these two, have the sum that is equal to a positive constant. So in other words, the f of 1 and f of 2 are called our foci, which is plural for focus. Okay, and it's going to be a positive constant from the xy point here on the ellipse. So that's what we're going to be looking at. Now we have two different types of ellipses. We have ellipses that are vertical, okay, where we have what are called our vertices, which are on the major axis because this is the longest side, and our co-vertices, which would be horizontal here. We also have what's called a horizontal ellipse, where now the major axis is horizontal, which means that these are called our vertices, and this is our minor axis, which has our co-vertices. So we do need to know the terminology here. So looking at these ellipses, we're only going to look at it when the center is at the origin. So those are the only ones that we're going to be looking at. So with an ellipse, you do have what are called our vertices, our co-vertices, and our foci that we talked about earlier. So we do need to find all that information. So the standard form is x squared over a number plus y squared over number, and it always has to equal to 1. Now, how are we going to determine if it's a vertical or horizontal ellipse? We're going to look at the numbers that are underneath. If the number is bigger, the a squared, if this number is bigger and it's underneath the y, then it's going to be a vertical ellipse. If the number of a squared is bigger and it's underneath the x squared, then it's going to be horizontal. So how we get the vertices and co-vertices is pretty straightforward, especially when we're working at center 0, 0. So we're going to get our a value, so we are going to have to take the square root, and we are going to have to take our b value. Our a value, which is going to be the largest one, is the distance from the center to the vertex. So notice here we're going to either add a or subtract a to get down here. And then our co-vertices is going to come from the b squared. So we're going to take the square root of b squared, and that's going to be the distance from the center to our co-vertices, which is our minor axes. Then our foci, these 2 points, we're going to use, it kind of looks like the Pythagorean theorem, but be very careful because notice there's a minus here. So it's going to be c squared is equal to a squared minus b squared. And that's how we're going to get the distance. We're going to get the c, which is going to be the distance from 0 to the focus. And the same thing's going to apply when it's horizontal. The only thing is that the a now is going to be the distance horizontal from the center, because that's going to be our major axes. So I have everything written here for you that you need to know, because you are going to need to know the length of the major axes, because that's going to be 2 times whatever your a value is, because remember, a is the distance from the center to the vertex of that ellipse. So first, let's look at the first one here. And it does have to be in standard form. So notice that it does equal to 1. It does have to equal to 1, and it has a plus sign here. So we have x squared over 16 plus y squared over 4. So notice that 16 is bigger than 4, and it's underneath the x. That means that this is a horizontal ellipse. So it's going to look like this. So the major axis is going to be at a horizontal. So now we're going to identify what our a is. So this is a squared. So that means a is 4. And this is b squared. So that means b is 2. Our center is going to be at 0, 0, because that's what we're going to be looking at. So how are we going to know our vertices? So remember, this is the distance from the center to the vertex. It's 4 units. So that means that we are going to move 4 units to the right and 4 units to the left. So these are our vertices. Our co-vertices come from the B. It's a distance from the center to the co-vertex. So this is going to move up vertically. So it's going to be 0, 2 up and 0, -2. The length of our major axis is 2 times our A value because that's our major axis. So it's 8 units long. And the length of our minor axis is going to be 2 times our B value, which is going to be 4. And then remember, to get the foci, you need to do C squared is equal to A squared minus B squared. So we get A squared was 16, B squared was 4. So we get 12. So C is equal to square root of 12, which is 2 square root of 3. And remember, we do need to tag along that plus or minus because we are going in both directions. The foci is always on the major axis where the vertices are at. So this is going to be 2 square root of 3, 0, and -2 square root of 3, 0. And that's all the information that we're going to need. So now we're going to go ahead and graph it. So we're going to put our center, which is at 0, 0. Now we are going to have to take the square root of 12. And remember that the square root of 12 is going to be less than 4, but bigger than 3. And it is more or less in the halfway point, so it's like 3.46, 3.5. So the focus is going to be right about here. And then 1, 2, 3, right about here. So this is our first focus and our second focus. And then our vertices are at 4 and -4. And then at 2 and -2 is, and there is our ellipse. But you do need to make sure that you do notate all the vertices, the co-vertices, and our foci. And notice that the length of the major axis, which is horizontal, because that's what we stated, it from -4 to 4 is 8 units. And then the minor axis from 2 to -2 is 4 units. So good job. Now let's do one over here where it's not in standard form. Remember that in order for it to be in standard form, this number has to be 1. So what you're going to do is you're going to divide every single term by that constant. So we're going to get x squared over 4 plus y squared over 25 is equal to 1. So now we're going to look 4 and 25. 25 is bigger. It's underneath the y. So this is going to be a vertical ellipse. So it's going to look like this. The center here is at 0, 0. I'm going to illustrate what our A is. Our A is 5. And our B is 2 because we have to take the square root. So now because the vertices are vertical, that means I have to add 5 and subtract 5 on the y-axis because this is vertical now. The co-vertices from the center, I got to move 2 units to the right and 2 units to the left. The major axis, the length of it is 2 times our A value, which would give us 10. Our minor would be 2 times 2, which is 4. To get our foci, remember we need to use the formula. So we get C squared is equal to 25 minus 4, which we get 21. And C is equal to square root of 21. And again, we're moving in both directions, so we do need the plus or minus. This time it is on the vertices, which is on the y. So this time it's going to be 0, square root of 21, and 0 minus square root of 21, because this time it's on the x-axis. So we're going to plot our information. Here's 0, 0. Then we're going to do 0, 5. Oops. I apologize for that. 0, 5 and 0, -5. The square root of 21 we're going to take, and remember that's going to be between about 4.6. It's going to be a little bit closer because the square root of 25 is 5, and the square root of 4, the square root of 16 is 4. So it's going to be about 4 point something. So it's going to be right about here, our focus. And our other focus is going to be right about here. Then our co-vertices are at 2 and -2. And there it is. There's our ellipse with the focus. And notice we did state it was vertical, so there it is. I do want you to complete the other ones on your own. Now, Writing the equation is kind of the same thing. We need to find out what our A and our B are. So it says here, write the standard equation of an ellipse with foci at plus or minus 5, 0, and covertices at 0, plus or minus 2. So remember, our center here is going to be at 0, 0. So I know it's going to be x squared plus y squared over something equals to 1. When they talk about covertices, this is the distance from 0. So that's our B value because we're talking about our vertices, okay? And if we look at this, our covertices, sorry, I meant to put this, our covertices is at 2 and at negative 2. That means that this is a horizontal because the covertex is vertical here. So that means that the vertices have to be horizontal. So that means that the B has to be over the Y. So this would be 4 here because it's B squared. Now I do need to find out A, but they do give me what the C value is here. So I'm going to do 5 squared equals to A squared plus B squared. So we get 25 is equal to A squared plus 4. A squared is equal to 21. And that's all I need. I need A squared, which is 21. And there is the equation for it. That's it. I do want you to try the next one. And then writing equations in standard form. So this is kind of the same thing as what we did with the circles. We do need to complete the square here. So we're going to get all our x's together. So we're going to get 8x squared. And then we have y squared minus 6y equals to 7. Notice that here I don't need to do anything. Here I do. So we are going to go ahead and take this number divided by 2 and square it. So we get 9. And we're going to add 9. Then we're going to go ahead and get 8x squared plus y minus 3 squared is equal to 16. Now this is an ellipse. Remember, the ellipse has to equal to 1, so we have to do one more step, which is to divide by 16 every single term because it does have to equal to 1. So you get x squared over 2 plus y minus 3 squared over 16 is equal to 1. And that would be our equation of that ellipse. So good job. I do want you to try the other one here, and then I need you to go to section 10.1 in the textbook on page 986, and I want you to do the problems 2, 6, 14, 18, 26, 28, 55, and 59. On 55 and 59, I only want you to write in standard form. I don't want you to find anything else. Good job.